Suppose if you have two vectors, we would have taken cos theta is equal to their dot product divided by magnitude of A, magnitude of B. If the dot product of the two normals is 0, that means the two planes are perpendicular to each other. Parallel lines can have same direction ratios. Since they can have same direction ratios, both the normals will have same vector form. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to learn about the equations of angle between two planes, angle between a line and a plane, and the distance of point from a plane in three-dimensional axis. So, let us study one by one. The very first one is angle between two planes. So, here I have taken two planes and here I have drawn the angle between them as theta. And here N1 and N2 are the normals, that is a perpendicular to the planes. So, angle between planes is nothing but it's an angle between their normals. When the normals of the plane 1 as well as plane 2 intersects, so the angle between their normal is nothing but the angle between the two planes. So, thus the vector form of this angle is same as the angle between the two vectors. Suppose if you have two vectors, we would have taken cos theta is equal to their dot product divided by magnitude of A, magnitude of B. Here also we are taking the normals as the vectors. So, therefore, cos theta will be is equal to N1 dot N2 divided by magnitude of N1 into magnitude of N2. Since the normals are considered as vector here, the angle between the two planes is given by cos theta is equal to N1 dot N2 over magnitude of N1, magnitude of N2. And the Cartesian form is again, we know that vector can be expressed in the form of xi plus yj plus zk. So, here when I consider normal, we generally express it as a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0. So, where d and d2 are the distance of a point is equal to 0. So, here a1x plus b1y plus c1z indicates the vector form of the normal. a2, b2, c2 in terms of coordinate indicates the vector form of the second normal n2. So, thus I said cos theta is the dot product of n1, n2 and hence the dot product is given by a1, a2 plus b1, b2 plus c1, c2 and their magnitudes, we know that magnitude is nothing but square root of the sum of the square of their corresponding values of x, y and z. So, that is why here a1 square, b1 square, c1 square and for the second normal it is a2 square plus b2 square plus c2 square. So, let us check now nature of planes in space. So, what does it indicates according to the angle or according to cos theta? Now, let theta be the angle between the two planes. We know their Cartesian equation in their forms. Now, suppose if the planes are at right angles, that is when theta is equal to 90 degree. What is the value of cos 90? It is 0. So, hence we get the condition that if the dot product of the two normals is 0, that means the two planes are perpendicular to each other. So, we know there the coefficients of x, y, z in both the planes. So, here we have a1, b1, c1 and here we have a2, b2, c2. If their corresponding ratios are in proportion, then we say that they are collinear or they are parallel. So, this is what we all take for both lines as well as planes. So, in case of lines, we have written the small letters a1, b1 plus a2, b2 plus a3, b3 is equal to 0 where a1, a2, a3 represent their direct ratios and here same a1 by b1, a2 by b2, a3 by b3. So, when they are in proportional, they are parallel. Similarly, in the case of plane also, if the dot product of the normals are 0, then it is at right angle. That is, they are perpendicular. If their corresponding ratios are in proportion, then they are parallel. So, let us take few problems related to the angle between two planes. So find the angle between the two planes. 2x plus y minus 2z is equal to 5 and 3x minus 6y minus 2z is equal to using vector method. So vector method means we have to write what is vector n1 and what is vector n2. We have to write their magnitudes and then we find the cos theta. So first let us write vector n1. So vector n1 is 2I plus j minus 2k. So how can we write? By looking at the corresponding values, or we can say the coefficients of x, y, z will give you the vector n1. Next we will take vector n2. So vector n2 is 3I minus 6j minus 2k. So this is vector n2. Now we have cos theta is equal to n1 dot n2, that is multiply their corresponding coefficients. 2 into 3, 6. 1 into minus 6, minus 6. Minus 2 into minus 2, plus 4. Whole divided by magnitude of vector n1 means square root of 2 square 4, 1 square 1, minus 2 whole square 4. Again magnitude of vector n2, 3 square 9, 6 square 36, 4 square 2 square 4. So here we are getting this value as 6 and minus 6 cancel, 4 divided by. So 9 square root of 9 is 3. We need to take only the positive values because it is clearly mentioned it is under the modulus. So whatever values you get, you have to take it only the positive values. 9 plus 36 plus 4 is 49. Square root of 49 is 7. So we get the value as 4 by 21. So therefore, theta is equal to cos inverse of 4 divided by 21. So this is the angle between the two planes. Next, find the angle between the planes whose vector equations are r dot 2I plus 2j minus 3k is equal to 5 and r dot 3I plus 3j plus 5k is equal to 3. So whenever vector equations are given, it is clear that this is our vector n1 and this is our vector n2. And again, we know that cos theta is equal to n1 dot n2 divided by magnitude of n1, magnitude of n2. Now let's take n1 dot n2. So multiply the corresponding values of I, j and k. So 2 3s are 6 here. 2 3s are minus 6 because we have minus 3. Minus 3 into 5 we have minus 15 divided by magnitude of n1 4 plus 4 plus 9. Again magnitude of n2 is 9 plus 9 plus 25. So we have here cos theta is equal to, under the modulus we have here. So 6 minus 6 get cancels. So we have minus 15 whole divided by root of, so 9, 17 we get, and here square root of 43. So when I say modulus, just take only the positive values. So therefore theta is equal to cos inverse of 15 divided by root 17 root 43. So this is the angle between the two planes. Next question. In the following cases, determine whether the given planes are parallel or perpendicular. To say that whether they are parallel, we have to check whether their corresponding values of x, y, z or whatever I, j, k are in proportion. To say they are perpendicular, we have to show that the dot product of the normals are equal to 0. So first let us write the normals here. So we have vector n1, that is 2I plus 1j, or we can just write it as j plus 3k. And vector n2 we will take. Vector n2 is here. We have x, I, y is minus 2. So we get minus 2j. And there is no z value. So if there is no z values, there is no k component. So therefore it is 0 into k. So now let us multiply n1 dot n2. n1 dot n2, 2 1s are 2, minus 2, 3 zeros are 0, plus 2 minus 2 get cancels. So we got the dot product of the two vectors are 0. So this implies theta is equal to 90 degree. So if cos theta is 0, that means theta is 90 degree. So therefore, we can say the two planes are perpendicular. Now by just seeing the corresponding ratios, we can say if they are not in proportional, obviously their dot product must be zeros if they are perpendicular. So therefore multiply and find it and show that it is 0, that means theta is 90. So therefore the two planes are perpendicular. Second one, 2x minus y plus 3z minus 1 is equal to 0. 2x minus y plus 3z plus 3 is equal to 0. You can clearly see here the first three terms here are one and the same. So that means our vector n1 is 2i minus j plus 3k, and our vector n2 is also 2i minus j plus 3k. So both vectors are one and the same. That means we can also see if you divide 2 by 2, it is same as minus 1 by minus 1, which is equal to 3 by 3, which is equal to 1 by 1. All are in proportional. All values will be in the form of 1 by 1. So therefore clearly we can cite they are parallel. We can clearly say they are parallel because we know that parallel lines can have same direction ratios. Since they can have same direction ratios, both the normals will have same vector form. That is 2i minus j plus 3k. So by looking at the equations of plane only, we can decide whether they are parallel. So just we have got the same vector equations here and directly we can write they are parallel. So if they are not equal, then it has to be perpendicular. In case if they are perpendicular, it has to satisfy the dot product as 0. If it does not satisfy, then obviously they are not perpendicular also. Next, angle between a plane and a line. So here I have taken a straight line which makes an angle of theta perpendicular to the normal. So this is a normal perpendicular to the plane, and I have taken a line here which makes an angle theta with respect to normal. Then with respect to the plane, it has to be 90 minus theta. So we know that angle between the plane and normal can be written as, if I take B, vector B as the direction ratios which is parallel to the given line, and vector n cap as the normal, then angle between the line and the plane is same as angle between the two planes, that is n1 dot n2 by modulus n1 modulus n2, and here we can take it as vector b dot n divided by magnitude of b magnitude of n. But I need here not theta, I need 90 minus theta because angle between the plane and the line is 90 minus theta. So that is why we take it as angle phi. That 90 minus theta, I have taken it as angle phi, and that phi can be written as sine 90 minus theta. So that 90 minus theta can be written as same as sine inverse of vector b dot n divided by magnitude of vector b magnitude of vector n. So this is the angle between the line and the plane. So here angle is in terms of sine function. Find the angle between the line x plus 1 by 2 is equal to y by 3 is equal to z minus 3 by 6 and the plane 10x plus 2y minus 11z is equal to 3. So first let us write what is vector b and what is vector n, that is the normal to the plane. Now here the equation of line is given, thus we can write vector b. Here they have given the direction ratios a, b, c. Hence vector b is 2i plus 3j plus 6k. What about the normal? The normal can be written by taking the coefficients of x, y, z, that is 10i plus 2j minus 11k. Now we have phi as sine inverse of modulus of vector b dot vector n cap divided by magnitude of vector b magnitude of vector n cap. So let's take sine inverse of modulus of b dot n. 2 tens are 20 3 2s are 6. 11 6 are 66. Whole divided by, let's take the magnitude of the vector b. So that is square root of 2 square 4, 3 square 9, 6 square 36. Next take magnitude of vector n, 10 square 100, 2 square 4 and 11 square 121. Clearly we can see a 26 minus 66 is, so therefore here I can write it as sine inverse of, so I'll get minus 40 here divided by 36 plus 4 40, 49. So 7 I'll get 100, 221 plus 5, 225. Square root of 225 is 15. 7 into 15. So cancel it. 5 3s are 15, 5 8s are 40, or I can just write it as sine inverse of 8 by 21. So this is the angle between the line and the plane. So a line is given, write the direction ratios of vector b. A plane is given, write the vector equation of normal. Take phi is equal to sine inverse of b dot n cap by magnitude of b magnitude of n. Substitute it and evaluate. Next, distance of a point from a plane. So whenever you have a plane here whose normal is given here and there is a point P, x1, y1, z1. So what is the distance between the plane as well as the point? That distance is measured with the perpendicular distance. So the distance of a point from the plane is nothing but the perpendicular distance from the point to the given plane. So wherever the point may lie. So suppose if you have a plane here, suppose if this is the point P, then exactly the perpendicular distance from plane to the point is nothing but distance of a point from a plane. So we have studied distance of a point from a line and here it is plane. So whose equations here are one and the same. So therefore the vector form is given by a dot n minus d over modulus, or we can say the magnitude of vector n, where n represents the normal of the plane. And in Cartesian form we can write it as ax1 by1 cz1 minus d, where a, b, c represents the direction ratios of the normal, and here a square, b square, c square we can write, and d is the distance of normal, and x1, y1, z1 is the coordinates of point P. So we have both vector as well as Cartesian form. Next. So note here, the length of the perpendicular from the origin to the plane is only d, because we have no x, y, z. So when I consider strictly the point as origin, whose distance or whose coordinates will be 0, 0, 0. So therefore x1, y1, z1 will be 0, and hence here if you put x1, y1, c1 as 0, the equation becomes d divided by square root of a square plus b square c square. So this is the Cartesian form, and again this is your vector form. Next, find the distance of a point minus 6, 0, 0 from the plane. 2x minus 3y plus 6z is equal to 2. So here let me take this as x1, y1, z1, and here we have a, b, c and d. So let me take the Cartesian form. Distance d is equal to modulus of ax1 plus by1 plus cz1 minus d whole divided by square root of a square plus b square plus c square. So d is equal to a is 2, 2 into minus 6 plus b is minus 3 into 0, c is 6, 6 into 0, d is 2, minus 2 divided by 2 square 4, 3 square 9, 6 square 36 square root. So here we have d is equal to minus 12 minus 2 divided by, so we will get it as 49, square root of 49 is 7, and the magnitude we will get it as 14 by 7. So when you cancel, the answer is 2 units. Next, Find the distance of the point from the plane 3x minus 4y plus 12z is equal to 3. So we know that distance of a point from the plane is given by d is equal to only d, because when you say the point from the origin, the value of x1, y1, z1, 0. So therefore, if you substitute x1, 0, y1, 0, z1, 0 here, a, b, c will also becomes 0 after multiplying. So again, square root of a square plus b square plus c square. So d is equal to, so what is the value of d here? Value of d is 3. So therefore, it is 3 divided by square root of a square is 3 square 9, 4 square is 16 plus 12 square is 144. So we get it as 3 divided by 144 plus 16, 169, square root of 169. So square root of 169 means it is 3 by 13 units. Next, find the distance of a point 3, minus 2, 1 from the plane 2x minus y minus 2z is equal to 0. We can clearly say we have a, b, c but no d. Here we have x1, y1, z1. So a into x1 means we have 2 into 3 plus b into y1 minus 1 into minus 2 plus c into z1, that is minus 2 into 1 minus d 0 whole divided by a square is 4, b square is 1, c square is 4. So under the square root modulus. So distance we have 6 plus 2 minus 2 plus 2 minus 2 cancels. Here we will get square root of 9, 3. So we get the value as 6 by 3, 3 ones are, 3 twos are. So answer is 2 units. So this is the distance of a point from the plane. Next, find the distance of a point 2, 5, minus 3 from the plane r dot xi r dot 6i minus 3j plus 2k. So we have x1, y1, z1 here. So we have r dot 6i minus 3j plus 2k is equal to 4. So r dot xi means we have a 6x minus 3y plus 2z is equal to 4. So now we have this in the Cartesian form, a, b, c and d we have. Or else by looking here only we can write a, b, c and this is our d. So let's check the distance. Distance is a into x1, 6 into 2, b into y1, minus 3 into 5, c into z1, 2 into minus 3. Square root of a square, 6 square is 36, b square minus 3, 9, c square 2, 2 square is 4, another square root. We have here d is equal to 12 minus 15 and here minus 6 whole divided by, this is 49, square root of 49 is 7. So on solving here, 12 minus 15 minus 3, minus 3 minus 6 is minus 9. So minus 9 divided by 7, or we can write it as 9 by 7 units. So this is the distance of a point from the plane. So this completes the syllabus in 3-dimensional geometry. So we'll meet you in the next session with a new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.